Right, today we're going to be discussing and showing how to install the hatch cover studs. This part of the build, I would say, is probably the most integral part of the build. The bottom line is, if your studs aren't mounted properly, if you're not getting a good seal on your hatch cover, you might have 5 minutes of fun with your rcSurfer, and that'll be it, because if we get too much water inside of the housing, your RC surfing experience is going to be an unpleasant one. So let's focus in on this installation. What I'm going to share with you, I've no doubt there are many other ways of doing it, but I can validate to say that what I've been doing with this installation has worked for the many RC surfers I've built. You've seen in my videos, I don't hold back in the surf, and it's a tried and tested system. So let me show you the details of how to go about doing it. You can see I'm loosening up what I call milled nuts. These are type of a nylon 4mm nut, and really has a restricted diameter, which in sense restricts the leverage you have on torquing the fastness of it. And that, I suppose, would be obvious to realize that you can't necessarily over tighten the nut. Whereas if you were using, let's say, a bigger levered securing device like a wing nut, you could actually end up over torquing your nut and actually drawing your stud out of your bond. So be cautious of that. I know these aren't available to many folk, they're not easy to come by, but even if you do have a wing nut, maybe grind down the length of the wings, or just realize that when you're fastening down this hatch cover, all you have to achieve is really compress your neoprene seal that you have on the opposing side. This is a 3mm neoprene seal, closed cell, and we just want to depress it by about 1.5 to 2 millimeters. So you don't need a massive amount of torque for that. Remember, just to reiterate what I said when we started with the hatch cover development, is that this board in itself, when it wipes out in the surf, I doubt would go more than 1 meter underwater, and there'll be very little actual water pressure trying to pressurize itself through the seal over here. Most of your water pressure is going to come from pressure from a wave breaking towards it, on top of it, from the board landing from a high drop into the water on the rail, or on the front, or on the back. So we're already deflecting a lot of that water pressure with the deflection rim around here. So really all we want is a seal. We've got a pretty wide flange over here. We've got a 15mm flange. We're running a 15mm neoprene seal around the outside here. So it is more than adequate just to simply nip up these 7 nil nuts. Just nip them up. What I do is I actually just depress the lid and turn it up tight, and then it works absolutely fine. Okay, we're going to want to be achieving a clean installation, a very strong installation, and so I'm going to share with you how to go about doing this. Okay, so in preparation for the job, just make sure we got the right hardware to start with. Stainless steel bolt. In this case, my thread length is 40mm long. Obviously I cut the head off and just clean it up on the grinder. And the reason I've got 40mm of length here is, first of all, I want the stud to reach through the width of the entire board, which is 30mm. We're actually going to be bonding the end of the stud to the opposing side of the board, and then I'm left with 10mm. And if you check your hatch cover, my hatch cover here is 4mm thick. My nil nut is just under 4mm, so that's 8mm, leaving me 2mm of for the 3mm neoprene, and once that's compressed, that'll be down to about 1.5 to 1 mil. So when I tighten down the hatch, I literally have 1mm of stainless steel stud exposed, which isn't going to be a problem. And it's also almost an indicator that we've tightened up nicely. I mean, you don't want to have a stud where you have this length of thread sticking out. You also don't want to have to sit and grind it down and file it down afterwards. So the preparation of the length is important, and I'll show you how we establish that when we install it as well. Okay, we also obviously got our our 15mm wide 3mm neoprene. And as I said before, if you can't get your hands on these nil nuts, try and find a smaller diameter wing nut as possible, because you don't want to over torque this installation. Okay, tools to do the job. We need a 4mm drill bit. You can see this drill bit here. I've put a stopper on it with a set depth, because the one thing you don't want to be doing is drilling right through your board, so this is highly recommended. You could just find a something that has a 4mm hole through it, fit it on there. You can either epoxy it in place. You can see I've studded mine in place, but there's many ways to make sure that you don't drill through your board. So you set that depth, and I actually hand drill the next 5mm into the foam, which obviously isn't hard. Little piece of silicone tubing, and I'll show you what this does for us. It helps us set the depth and also helps us keep the thread itself clean. We use a syringe as an hydraulic to insert the epoxy. We have a very slow set epoxy. I use the Epidermics range 372. Proven itself to me over and over again in many different applications, but this is a very slow setting epoxy, and that's the reason we want that, is that it saturates itself into the open cells and really does a good job. A little Dremel tip tool, a little round tip that I use just to nail in on the holes that are going to be installed in the hatch cover itself, so when I'm drilling it doesn't drift. You want an accurate drill. You only get one chance at drilling a hole. This helps, and I'll show you. And then clearly some kind of hand drill to be able to drill the holes into the board. So the first thing when we start this process is to just double check that your hatch is fitting well within your deflection rim. There's no high points or anything around. Then, as you can see on my template here, I have 7 mounting points. There's no doubt that if this was a hatch cover simply to be sealed, that we could construct it in a different way maybe, and even just end up with 2 fixing points to be able to compress it down to seal it entirely. However, in this case where we have our Surfer mounted on top, it's not just a case of sealing the rim of the hatch cover, but it's also a case of stabilizing it. We have a lot of stresses and strains put on this hatch cover from the Surfer being mounted on it. So what we want to have is a good even distribution around the peripheral of the hatch cover of the studs sharing the load. So in my case I use 3 studs up the side and 1 in the front. Let's mark it out accurately. If you don't have a template, you can just measure it out. You want your stud to be located as close to the center of the flange as possible. Right, a little tip here, excuse the pun. When you preparing to drill the holes in the hatch, like I always say, you only get one chance at drilling an accurate hole. You want to prepare yourself to drill it as accurately as possible. The problem you might find when you're drilling into this linen cloth is that your drill bit finds the wrong little square, and you drill your hole out of where you want it to be. So what I do is I just use a little Dremel tip, round tip, and just Dremel a little radius where I want my drill bit to go. Right, so you can see this little Dremeled half moon here, almost like a punch when you punch in a piece of steel or wood, just to drill accurately. Very important, you don't want your drill bit running around on this peripheral and getting your alignment out. Remembering just a quick chamfer. We have our holes, our edge cover holes, ready to line those up on the board. So we start off by scribing our holes, not to drill, but simply to mark where we want to put our tape. We're going to tape up around the holes to ensure that we don't have epoxy mess everywhere. Right, so you can see I've taken the time to tape up around each hole, nice and flat. We're going to be working with epoxies here, we're going to be working with threaded studs, and what we don't want after this process is to either have our hatch cover bonded to the board. We don't want to have the thread on our studs fouled up with epoxy. We want this to be a good clean operation, so preparation is everything. And you're going to see through this process that when we finally remove the hatch and remove the tape and the little silicone tube that keeps the stud clean, it's going to be a 100% clean, neat operation, and that's what we want. So with my cordless, got my 4mm drill bit on. I have this stopper that's going to prevent me from drilling too deep. It's going to come up against the hatch cover. I have the depth of my bit set at 30mm, which is the depth of my board, but remembering that I'm drilling from the hatch side here, so effectively that's going to be a depth of 34mm, and the last 4mm we're going to drill out by hand. So you can also see what's nice about this stopper here, it's got quite a wide diameter, so when I'm drilling down and I touch the hatch cover, it'll actually ensure a perpendicular hole. Right, so what I'm doing here now, I'm actually cleaning the foam out right down to the opposite side of the board, so that this hole is open all the way through to the fiberglass on the other side, because when we inject the epoxy in here, the epoxy is actually going to bond onto the opposite side of the board fiberglass layers, strengthening the bond even more. Much like they do to the real surfboards with the surf plug systems, actually bond it to the opposite side, the deck side of the board. In this case, we're actually going to be bonding the stud to the whole side. If you have access to air, good idea to blow the holes out, get all the foam. There we have our holes in our flanges, ready to receive the studs. See nicely the tape's just preventing any mess or leakage. Rim's nicely protected there. So the next stage of this process is to fit the actual stainless steel studs. You'll see here, once I cut the head off the stud, I actually put a sort of a 45-degree bevel on the end of the stud for two reasons. Number one is to create more surface area for the epoxy to bond to, but the other thing is you want to maintain the actual manufactured thread start on your stud. Don't use the cut-off side, because sometimes your thread entry could be a bit crude and actually damage your nylon knurl nut. So stick to using the manufactured thread end. The end you've cut it off, give it a sharp bevel, so when we actually insert it in, it gets a nice surface area bond, especially to the opposite side of the board. Okay, the other thing is soaking all the studs in acetone. You can use some type of degreaser, but you find a lot of nuts and bolts, when they manufactured or coated with a light layer of oil, just to protect them in storage from any surface rust. So make sure, you can actually see this nut how clean it is. Make sure that you clean your studs well, otherwise your epoxy is not going to bond, your thread of your stud is not going to bond well to the epoxy that's in the hole. So take the time just to clean these little guys perfectly. Right, so with our stud nice and clean, the next step in the process is the little silicone tube I was talking about. You can see I've taken it here and cut it into little slithers of about 3-4 millimeters. And what we do with these little slithers, we fit them over the stainless steel, top of the stainless steel stud, and we wind it down to our desired length, which in this case is 10 mil, that we want to expose outside of the hole. So this becomes a gauge for our depth, so that we have a consistent exposed portion of the stud, besides being a measure for us to ensure that we have 10 millimeters of thread exposed beyond the flange. It also keeps the threaded area clean, when we screw this into the hole as the excess epoxy oozes out. And then when we place our hatch cover on top of all the collected studs to ensure correct location, it floats our hatch cover away from the epoxy so that our hatch cover doesn't bond to those various points. Right, so before we just dry fit our studs, just take a round file, sharp pointy line file, just put a small chamfer inside of the holes, and then we just want to dry fit all the studs, put them in position. You don't want to find things are getting pear-shaped once you've got all your epoxy on everything. It's going to be a bit messy and a bit difficult to actually sort the problem out. Right, just check our hatch holes location, lining up nicely. All looks good. Next step is to mix up your epoxy to your manufacturer's mixing ratio and specifications. Fresh mixing stick, just to load the syringe. So with our syringe loaded up with the epoxy, what you want to have ensure of, which I should have mentioned earlier with your syringe, is that the diameter of your syringe nipple fits snug inside the hole that you're going to be injecting the epoxy into. You don't want it to obviously be too big and you don't want it to be too small, and most syringes have got a slight taper on them, so this fits in nice and snug. And I'm going to inject my epoxy in, and what I want you to listen for is a slight, almost like a crackle sound, and that's actually the epoxy as I'm putting slight pressure on it, driving itself into the open cells. You don't want to put too much pressure on it, just enough pressure to hydraulic it into those cells, and then hold it there for a few seconds before releasing it and moving on to the next hole. You can almost see the epoxy, due to the pressure, pop out. Working neatly is paramount. Just saves a lot of unnecessary work, and also just always seems to present a better product. You just leave this for about half an hour, because it's a slow curing epoxy. Not in a hurry. I want to leave it to saturate, the epoxy to saturate into the open cells of the hole inside before I drive the studs in and expel any of the excess epoxy that gets taken up by the volume of the stud. Right, so we've given that enough time for the epoxy to saturate as best as it can down in the hole, into all the open cells, down to the bottom layer of the board. And now we need to take our stainless steel stud and fit it into the hole. The way to do this is to take advantage of all this threaded area we have here to get a really good bond. If we just had to push the stud down, all we'd really do effectively is displace the epoxy that's in the hole. That would ooze out, and we would maybe have a couple of areas that are poorly bonded to the epoxy. So what we're going to do is, when we place this in the hole, we're actually going to rotate it as if we're screwing it into a threaded hole, patiently drive it down. In that way we're going to seek to get the epoxy to flow into all the threaded parts of the stud and give us a real good location. As we're doing this, almost have like a, you can see the stud pushes itself up, that's fine. Just drive it in, make sure it wets itself out nicely. A bit of epoxy around there, we'll just leave that for now. Some little air bubbles popping out. Rotate it, screw it in. Now that we have all the studs in, we're going to spend some time cleaning around the excess epoxy and position them to the holes. Taking a closer look at what we got here, you can see the stud, you can see the little silicone ring, and then you can see the epoxy around the outside. And that's a good sign of good saturation in all the holes. And what we're going to do now, we're going to place the lid on top, and that lid's actually going to rest on that little silicone ring. That'll keep it separate from the epoxy. We need to put the lid on to ensure good location. And then we're going to tape across the studs, because the studs do have a tendency to want to push themselves up because of the effect of the epoxy inside, which is also a good sign that we've got adequate epoxy in there. And so to ensure good location of the studs, we're going to fit the hatch covers on top. As I said, the hatch cover is going to press down on that little silicone slither. Now what we're going to do, because the studs do have a tendency to want to lift out of the hole, we're going to tape them, stretching the tape across, down. So that's as far as we can go today. We'll leave that to cure until tomorrow. We'll remove the tape, remove the hatch cover. So we're back. It's been overnight. Epoxy is nicely cured. Take off our tape, pop off our lids, start removing the tape and the silicone slithers to clean up our stud installment. Little neck. Take it off, just give it a few little bumps. Tape from either side. Just whips out all the epoxy. Go. Good, solid, clean stud installation, ready to take on the ocean. Nothing wrong with that. Absolutely clean, solid stud installation. You can see how nice and clean the installation of the stud is. There's not a drop of epoxy around the stud that I've had to remove, other than just lifting off the tape and the silicone slither. It's for all of them. It's a real streamlined installation with good preparation. The finish is very easy. Now that we have our studs cleaned and all prepped, the holes in the hatches are still 4mm, as the studs are 4mm, and what I find is that just is a little bit too tight for on and off. So what I do now, just re-drill these holes to 4.5mm just to give them a slight bit of relief, so that putting the hatch cover on and off is that much easier. On she goes. Hatch cover is fitting great. Now we're going to pop the hatch covers off and fit the seal. Right, so we got our studs, we got our holes in our hatch cover. We're now going to place our seal, and a lot of people ask me why I put the seal on the hatch and not on the actual flange of the board. I think it's obvious to realize that it's going to be a lot easier to fit the seal onto a flat surface without any obstruction as the studs are here. Also realizing here that the seal is the same width as the flange. We're running a 15mm flange here. The seal's much the same. And what I try and do when I actually bond the seal to the hatch cover is that I keep it a millimeter in, so when it fastens, you can see here, it actually just nips over this edge over here and gives you like an extra little seal when you tighten your hatch cover down. Right, you want to be comfortable when you're doing this. This is a 3mm neoprene close cell seal. It's got a contact strip on the back. Don't pull too much of that contact strip away when you're doing this, because when this stuff sticks, it really sticks and you're not going to be able to relieve it. So let's start off. Just use your sort of 1mm in from the edge as a guide, and just take your time as you going along. You can see it in my back finger here. I'm pulling the paper away and just placing the seal. Don't stretch the seal out, otherwise you just minimize its compression. Right, when you get to the joint over here, just lay it over where you started and snip it about 1 millimeter longer. And you can strip this off, put it edge to edge there. Spot on. Right, so now we've got our seal on, and what we need to do is put holes in the actual seal. And the biggest mistake you can make is try and take a drill bit and drill those holes, because it'll just tear the neoprene on this side. The actual adhesion on the neoprene will grip onto the drill bit and tear a massive hole over there. The good thing to do is to take a little brass tube, 4mm diameter, take your countersink drill bit, push it inside the brass tube, put like a reverse edge on it, so you're sharpening it up. So we just use this now as a little punch through the hole, back to the little block of wood. And then we have a nice clean hole through our neoprene. Seals on, holes punched, fitting like a glove. Right, so put our nil nuts on. You can see here, as I'm tightening them on, drawing the hatch cover down below the deflection rim. About as tight as it needs to be. we look closely here, we've got our deflection rim, our hatch cover is tucked nicely behind it. We've got our null nut with our just 1mm exposed, and that's, I have to say, is a great seal, proven itself over and over to work well.